Hi, hello, ಪ್ರಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ. ವೆಲ್ಕಮ್ ಟು ಕರ್ನಾಟಕ SSLC ಆನ್ಲೈನ್. ಓಕೆ, ಸೊ ಹಿಂದಿನ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು BPT, ಕಾನ್ವರ್ಸ್ ಆಫ್ BPT, ಓಕೆ, ಸೊ ಅದು ಪ್ರೂಫ್ ಮಾಡಿದ್ದೇವೆ. ಓಕೆ, ಇನ್ ದಿಸ್ ಟುಡೇಸ್ ಕ್ಲಾಸ್ we will do exercise 2.2 or nothing but 6.2 as per the NCERT textbook. Okay, so this is purely the application of BPT and the converse of BPT. Okay, so when to use BPT and when to use converse of BPT will come to know. Okay, see the first one. So figure is given, so two figures are given here. What he has said, in both the figures, okay, DE is parallel to BC. The line DE is parallel to BC. Okay, now you need to find in the first figure EC and AD in the second figure. See, in the last classes I have already explained you, in a triangle if a line is parallel to the third side, you can make use of a BPT. Okay, you can directly make use of a BPT. Okay, so I will make use of BPT. Okay, and when I make use of BPT, I can write the intersecting sides ratio are equal. The intersecting sides ratio means AD by DB equal to AE by EC. Okay, so ratios are equal. When I write in the ratio, when I write in the form of ratio, the only unknown becomes EC. So thereby you can find the value of EC. And in the second figure, again when I write AD by DB equal to AE by EC, the only unknown is AD. So it is simply the just writing in the ratio form, isn't it? Okay. So we will write. So for the first figure, okay, so using BPT, I can say using BPT, you never use BPT unless there is a parallel line. Okay, so here is a parallel, so I can use the word using BPT. Okay, using BPT for the first figure. Okay, now so I can write ratio. Okay, AD by DB. Okay, AD by DB is equal to AE by EC. Correct? Fine. I'll substitute the values. What is AD? 1.5. What is DB? 3. AE 1, and we need to find the EC. Correct? Fine. So this is in decimal and this is in whole number or a natural number. So I'll convert both the numbers in the same form. I mean both as a natural number. So I'll multiply 10 to both the numbers. So 1.5 becomes 15, 3 becomes 30. Okay, is equal to 1 by EC. Correct? So it is 15 times 1, 15 times 2. Cross multiply, you will get EC equal to 2 centimeter. Correct? EC equal to 2 centimeter. Simple. Okay. Similarly, we'll use BPT for the second figure. Okay. Again, using BPT. Okay, the second figure. For the second figure, again you write ratio. Okay, so don't go with the letters. Okay, the letters may be different, but you should understand what is BPT is. Okay, AE by EC. Okay, AD we need to find by DB. It is given 7.2, AE 1.8, EC 5.4. Okay, fine. So AD equal to 7.2, you can shift other side, so this will be multiplied into. Now you can see both decimals have a one digit after decimal point, so you can neglect the decimal point. It is as good as 18 by 15.4. Now you can cancel 1s and 3. Okay, so AD equal to, if you're okay with the decimal division by whole number, it is fine. Otherwise, I'll multiply both numbers with the 10. So 7.2 becomes 72 and 3 becomes 3 into 10. Okay. Now 3 times 1, 3 times 2, 3 times 4, you'll get 24. So AD equal to 24 divided by 10, nothing but 2.4. Okay. So therefore AD is going to be, okay, 2.4 centimeter. 2.4 centimeter. This is how you can find a unknown by using a BPT. Okay, hope you have understood. Fine. Next one. Second main, first bit. See, Here they given triangle called PQR. E and F are the points on the side PQ and PR. Now in this case you need to check whether the intersecting line EF is parallel to QR or not. Okay, so this is nothing but we have to make use of a converse of BPT. Okay, as I told you, the difference between BPT and the converse of BPT. In BPT, the given statement becomes the proof in the converse. Similarly, the proof in the BPT becomes a given statement in the converse. Okay, so you can see here, first we will consider triangle. Okay, so consider triangle PQR. Okay, EF, okay, intersects, okay, EF intersects at PQ and PR sides respective. Okay, so we'll draw triangle. Okay, PQR. Okay, now so just to let me take EF. So I'm not saying EF is parallel. Okay, we just need to check whether EF is parallel or not. For that we will make use of the condition. Okay, what condition is? See, as per the converse of BPT, if you are able to show the intersecting sides ratio, okay, if this line divides the intersecting sides in the same ratio, I mean PE by EQ is equal to PF by FR, I can say by converse of BPT that EF is parallel to QR. Okay, so what we do, we try to first find the ratio of PE by EQ separately and also PF by FR. If the ratios are same, I can say EF is parallel to QR. We'll see. Now, so I'll go with the first PE by, okay, PE by EQ. What is PE? Given 3.9 centimeter, so we can write 3.9. What is EQ? 3. Fine. So I'll multiply with the 10 both the side, 39 by, okay, 30. Now we can divide them with the 3 table. Okay, so I'll get the 13 by 10. Now what is the HCF of 13 and 10, which is 1? HCF is 1. It means the fractions are in the simplest form. No need to divide. Further division is not possible. Even you can write in decimal as a 1.3, but we will keep in the fraction form. Now I'll check for the second side, PF by FR. Okay, PF by FR. What is PF? 3.6, FR 2.4. So you can neglect decimal point as the same digits are there after decimal point, so it is nothing but 36 by 24. Now 12 table, 12 3s are 12 2s are, so we'll get 3 by 2. Now we can observe that, okay, we can observe the ratios, okay, the ratios at the intersecting points. Okay, EF, PF by FR. Okay, so these things, okay, are they equal? We can see the values 13 by 10 is not equal to 3 by 2, so they are not equal. So when they are not equal, no need to make use of converse of BPT. Converse of BPT you can use only when the ratios are equal. So here they are not equal means you can straightforwardly write that, okay, EF is not parallel. EF is not parallel. EF is not parallel to QR. EF is not parallel to QR. This is how you have to do. Okay, we'll see the next one. I have selected some questions. Okay, I have selected first bit and third bit. Okay, fine. We can solve by two methods. First one, we will make use of the ratios. Okay, ratios like PE by EQ and PF by FR. But here EQ and FR are not given. But as a whole it is given. The length of whole side and part of the whole side is given. So we can find other part. Okay, so first we will find the other part. How? So you can find okay, EQ. Okay, so I can find EQ as PQ minus PE, correct? Now you can get the part from the whole, isn't it? So PQ is 1.28, okay, minus PE is 0.18, okay. Now, so 8 minus 8 0, 2 minus 1 1, 0.1 minus 0 1, 1.10, okay. Similarly this side FR also you can find from the complete side. It is PR minus, okay, PF, correct? What is PR? 2.56. What is PF? 0.36, okay. Fine. Now 6 minus 6 is 0, 3 minus 5 minus 3 2, okay, 2 minus 0 2, 2.20 centimeter FR. Now we will make use of a BPT, okay. Yes, using BPT. Yes, using BPT, it is PE by EQ, okay, equal to PF by, okay, FR, okay. Okay, so sorry, first not just BPT, because we don't know EF is parallel or not, so we'll just find just ratios, okay. Find ratios, because they have not given EF is parallel, that only we need to find, so don't write anywhere using BPT, okay. Just you can write P by EQ and PF by FR. So we'll check the each, okay. So we'll check each case. PE, it is 0.18, okay. EQ, we have just got a 1.10. Now, so you can multiply with the 100 on both the side. It is 18 by 110. So both are divisible by 2 table, okay. 2 nines and 255, correct? So 9 by 55 I am getting for the first ratio. Similarly, I'll find for the other ratio, okay. I'll see other ratio as PF, okay, by FR. What is PF? 0.36, okay. What is FR? FR we have got a 2.20, okay, 2.20. So again, after decimal 2 digit, both numerator and denominator, so multiply with 100, or we can just neglect the decimal point. 36 by, okay, 2 to 20, okay. So it is divisible by 4, okay. 4 9s are 36, okay. 4 5s are 20, and again 5s are 20, so you're getting 9 by 55, 9 by 55, okay. Now we can compare the ratios, okay. So this implies, okay, PE by EQ, okay, is equal to PF by FR, okay. So if, okay, if the ratios are same on the intersecting sides, I can say EF, sorry, yes, EF, okay, is parallel to QR, okay. EF is parallel to QR, but I need to write reason. So the reason here is, you can write a converse of BPT, because we have proved the ratios are same, okay. When ratios are same, I can say that this intersecting line will be parallel to the third side. This is as per the converse of BPT, which we proved, okay. So I can say EF is parallel to QR, okay. Fine, this is one way, okay. This is one way. The other way also you can find, okay. So the other way is, okay, so I'll explain here. So the other way is, even you can take, okay, even you can take ratios of, okay, smaller by whole. That is also actually part of BPT. By adding +1, you are going to get that result, okay. So you can write a part, nothing but PE is a part of a complete side PQ. So PE by PQ, okay, we'll check for first. So PE 0.18, okay, PQ 1.28, okay. So again you can write simply as a 18 by 128. See, you should not compare without simplifying the fractions. Always you have to simplify the fractions. Keep it in its simplest form. It means the HCF of numerator and denominator should be always 1. That then only we can say it is simplified. Okay. So I'll go with the 2. So 2 9s are 2 6 and 4. It means 9 by 64. Similarly, I'll go with again same thing on the other side. PF by PR. Okay. So what is PF? It is 0.36. Okay. And the PR 2.56. So shall I write simply as 36 by 256? See here, if you see the first result, 18 2s are 36, 128 into 2, 256. It means the ratio will be same. Just by seeing these ratios you can get the answer. Okay, so I'll go with the 4. Okay, 4 9s are, okay, 4 6 are 24 and 4 4s are 64. Again you will get a 9 by 64. So as the ratios are same, I can say PE by PQ is equal to PF by PR, and hence I can say even EF, okay, is parallel to QR. Reason is converse of BPT, okay, converse of BPT. That's it. Okay, so I hope you have understood about the today's class. Fine, so keep practicing. Okay, so in the next class I'll bring some more questions and we try to analyze each and every question and get to know when to apply BPT, when to apply converse of BPT. Okay, fine. Thank you.